Assalamualaikum warahmatullahi wabarakatuh. Today, our group represent IoRe project. IoRe means for Internet of Things for Recycle Management. Our team have 4 members. First is me, Azhaika bin Abdul Hamid. Second one is Amirul Amil bin Muhammad Aminuddin. The third one, Muhammad Nuhimsah bin Muhammad Rizam. Fourth one, Muhammad Farouk bin Nasar. And our supervisor, Encik Muhammad Hafiz bin Ismail. If you walk along our streets, you often see recycle cage is always full. Rubbish doesn't fit in the cage and get blown around by the wind, creating sanitary conditions that attract dogs, birds and rodents. So, in northern Malaysia, recycling in our city done by Environment Aidaman Sdn Bhd. After series of interview and discussion with Aidaman, we know that they had no system to measure the capacity of the recycling cage, no automatic system to wirelessly monitor the recycling cage content via phone or website. There is no effective system to arrange the collection schedule to collect recyclable material in the recycling cage. Aidaman had to spend a lot of money on a large fleet of vehicles to service all this recycling cage. Taking this to account, as well as number of other environmental and economic factors, we have developed a new technology to solve this problem using IoRe. IoRe is a smart system to monitor the recycling cage or bin contents, and schedule arrangement can be made based on this data for recycling collection. This embedded system measures the recycling cage or bin capacity using sensor, transmit the data using Wi-Fi and LoRa device, solar as power source, Android application and IoT platform to monitor real-time data. This system has been successfully implemented at UCT Malaysia Police Recycle Cage and at Masjid Tuanku Syed Faizudin Putra Jamalulai Recycle Bins. In IoRe, it has 3 main objectives. For the first one, to implement a sensor to detect the contents in recycle cage and recycle bins. The second one, to design a system to monitor the contents of the recycle cage and recycle bins via phone and website in real time. Third one, to arrange the schedule collecting recyclable materials for recycle cage and recycle bins based on stored data at IoT platform. IoRe system split into 2 systems, one for recycle bin and second one for recycle cage. The comparison of these 2 systems shown in this table. So the main difference between these 2 systems is the sensor used. So for the recycle bin, it uses ultrasonic sensor. For the recycle cage, it uses LiDAR sensor. And for the power source, recycle bin use lithium battery, 7.4 volt. Recycle case use solar power system, which the battery capacity is 11.1 volt. And for the cloud service, IoT platform, software used for schedule management. For the recycle bin and recycle case, it use the same system. But for connection or device used to transmit data to internet, for recycle bin, it use Wi-Fi connection. Recycle cage, it use Wi-Fi connection and LoRa device. For recycle bin system, the system divide into 2 slave and 1 master, where slave used to collect and transmit data of sensor to master using Wi-Fi connection. Master used to collect the transmitted data and upload the data to Blink application and TeamSpeak website. The data uploaded consists of battery capacity, current and voltage used, recycle bin capacity, air temperature and air humidity that this data get from slave and master. In slave embedded system, it use ultrasonic sensor for measuring the recycle bin capacity, and this picture show the block diagram of the slave embedded system, and this one show the prototype of the embedded system, and here one is the flowchart of the slave embedded system. In master embedded system, it also uses ultrasonic sensor for measuring the recycle bin capacity, and this picture shows the block diagram of the master embedded system. This picture shows the prototype of the embedded system, and here we cut the flowchart for the master embedded system. For prototype, this picture shows how the embedded system will be placed at recycle bin scan. As you can see, the embedded system will be placed behind the recycle bins, and the ultrasonic sensor will be placed under recycle bin lid. For recycle bin plastic and paper, the embedded system will be placed at the same spot. Here is the result for recycle bins system after the master has transmit the data to Blink application From here, we can monitor the capacity percentage of each recycled bins, battery percentage for each bins, current being used for each bins, battery voltage left for each bins, air humidity, and air temperature. So, all this data can be monitored using Blink application in real time. Here is the result at ThinkSpeak website. At ThinkSpeak, we can monitor the data in graph for data analysis. And from this result, we can monitor the bin capacity changes time, maximum or minimum current being used, air humidity, and air temperature. Furthermore, this data will be stored in ThinkSpeak database. This project have been implemented at Masjid Tuanku Syed Faizuddin Putra Jamululai on 5 March 2022.
Maksudnya kita nak kalau dicekkan dia letak. Sepatutnya sekali tipet kalau kita pakai lebih kurang banyak sangat memang kena letak. Sebanyakan terbakar. Lepas tu kalau macam litik air ni kita tak payah jaga temperature dan dia punya boleh charge sekali.
Nantilah dengan YB Exco sebelah selesai sidang media insya-Allah YB bersama dengan
Next system, we have recycle cache system that will be used at recycle cache. This picture shows the overall block diagram of this system. First, LiDAR sensor will measure the recycle cache capacity for plastic, cans and paper slot. For measuring the recycle cache system, we call measuring recycle embedded system, which is use Arduino Nano as microcontroller. After Arduino Nano had collect the measured cache capacity data, it will transmit data to ESP32 microcontroller. After ESP32 had collect the cache data, it will transmit the data to receiver block diagram using LoRa device. Overall, transmitter embedded system it use solar as power source. After the receiver block diagram has received the data, it will transmit the data to Blink application and ThinkSpeak website. For receiver embedded system, it use lithium-ion battery or DC adapter as power source. As we know in recycle cache system, the system is divided into two main component, one for transmitter and another one for receiver. So for transmitter, the system is divided into three systems, one for measuring the recycle cache capacity, another one to transmit the data to receiver, and the third one is the power source where we are using power source solar powered system. So over here, you can see the block diagram for measuring the cache block diagram and the flowchart, and we got the transmitter embedded system block diagram, and here is the flowchart. Again, we got the power source solar power system, and this is the block diagram. Over here, we got the flowchart. First, as you can see, we're using the LiDAR sensor that we place in the cache, and over here we got the solar charge controller, and in the box we got the battery for the solar power source, and here we got the relay timer. And over here you can see the embedded system for transmitter and measuring recycle cache capacity, and here is all the embedded system that we placed on the same PCB board. For the solar system, here we show the block diagram and flowchart of the system. So solar panel will be placed on the roof of the recycle cache, and PWM solar charger controller will be put at front of the box. Here we show how to use the relay timer. First, you can see the transmitter embedded system in off state. To on this transmitter embedded system, we need to set the on time and set the off time. And you can see the transmitter embedded system is on after we have set the on and off time. After transmitter embedded system has transmit the data, the receiver embedded system will receive the data using LoRa device. Here we show the block diagram, flowchart, and project prototype for the receiver embedded system. From this experiment, what we do is to test the LoRa connection capability. We identify that data had lost after 350 meters due to Unimet topology, and sometimes the data is not received. Because of Unimet topology is high, LoRa signal is being blocked. From this table, you can see the LoRa device signal parameter based on the range we had experimented. So this table shows the condition or state of the recycle cache after we have changed the capacity of the recycle cache, and this table shows the cache capacity reading in cm and percentage. In transistor embedded system, we have placed current sensor to measure the solar current had been harvested and current being used by load. So this picture show the data at ThinkSpeak website, and this table show the solar current maximum and minimum that current can be harvested, and for the second column is for the load current that being used by the load. Also, in transmitter embedded system, we have placed air temperature and air humidity sensor to monitor the air temperature and air humidity. This picture show the data at ThinkSpeak website. So from here, you can see the table of the maximum and minimum temperature that we can get. Also, we have the air humidity, which display the maximum humidity and minimum humidity that we can get. For collection schedule arrangement, we can make the schedule based on average recycle cache data. For now, the location for recycle cache is at Kotsam, Masjid Tuanku Syed, and PTSS. From data we had at ThinkSpeak website, we can make a schedule arrangement using average cache data for each cache. As a calculation, based on first objective, we want to implement the sensor to detect the contents in the recycle cache and the recycle bins. So this objective have been achieved because we are using the ultrasonic sensor to measure the recycle capacity in recycle bin, and LiDAR sensor to measure the recycle capacity in recycle cache. For the second objective, we want to design a system to monitor the content of the recycle cache and bins via phone and website. So this have been achieved because we implement a real-time monitoring data using the Blink application and ThinkSpeak website. For the third objective, we want to arrange the schedule for collecting recyclable materials at recycle cache and recycle bin based on stored data at IoT platform, partially achieved because for now, the schedule system, user can see the average capacity for each recycle bin or cache via phone and Blink application. So based on this data, they can decide which recycle cache they want to pick up first based on this data lah. Also, at Blink application, it provides location for recycle cache and user location, and from this, user can know the range between recycle cache and user location just using Blink application on their phone. By using this IoRe system in city, it provides a solution in waste management, and by providing this solution, we have achieved United Nations Sustainable Development Goals, which goals number 11, which is sustainable cities and communities. So in the recycle bin system, the system still need to be improved by recode the program code, so find the bug in the code. So basically most on the program code. And for the battery, for now the recycle bin using the battery, so we need to solve this by using the direct supply like a direct current and recycle bins, or we can use the solar power system to power up the system. And for the IoT system, for in future work, we can create our own Android application, our own database, our own website, and this all the system just only for our IoRe project. And for the recycle cache system, the system is working perfectly, but the system is big a prototype. So in future work, we need to combine all this embedded system in one system to make it smaller and more friendly user. So for now, the sensor for the recycle cache use LiDAR sensor, which is cost high, very high. It's kind of RM200. So we need to reduce the cost by using another sensor like reliable and can measure the recycle cache content and not many error lah.
So after that, for the now we are just implementing circle cage system at certain place, not all place area. So for future work, we can implement this recycle cage system at Masjid Al Kofur, at Padang Lati, Masjid Al Arifin, at Padang Katong, and Masjid Al Ala, Bohor Tamak. So that's wrap up our IoRe project for this time. Thank you for your time. See you later.